Hello, this is Dr. Aydin from Ankara University, Turkey. Welcome to my video on integrating the ordinary least squares OLS method along with tentative solutions into PCES calculations. A Google Sheets tool suggested by Aydin is introduced for this integration using a data sample. First, when we click on the link in the article, we will see this screen. The first page illustrates an example step-by-step process as explained in the technical report. The second page is a blank template that retains the formula from the first page and they should be adopted for the new dataset. For this tutorial video, I prepared a hypothetical dataset before introducing data into the blank template. As you can see, we cannot enter data in this window because of view-only mode. To do our calculation, we should copy the blank template and add a new spreadsheet using our Google mail address. And we should pass it into our spreadsheet like this. Okay. And we can label it like my PCES calculations. Okay. For illustration, I will use this sample data. Suppose that there are two missing data points, one at baseline phase between sessions 4 and 5, and one at intervention phase between 9 and 10 sessions. Firstly, I am copying this data and pasting in my file. Okay. After entering the data, I can now calculate the PCES value by integrating OLS with tentative solutions into the calculations, following this step-by-step process as explained in the technical report. But recall, I should adopt the formula in the template according to my data. As a note, this template is used only for PCEStrend calculations, that is, when the baseline data for our sample show a therapeutic trend, we can use this template to calculate the effect size for PCES. For detail, please see the technical report. As the first step, we should address the missing data issue if there is. We have two missing data points in our sample, one from baseline and the other from intervention phase. For the baseline missing data, we need to add a row between sessions 4 and 5. I hover over the row of the fourth session and right-click the mouse, then click Insert one row below. In our dataset, we need to repeat this process for the intervention phase. To do this, I hover over the row for 9 session and right click again, then insert one row below. To provide sequential order in the time session column, we need to rearrange the order of time sessions sequentially. I select at least 2 rows, then expand them to the end of the dataset. Okay. As the second step in the missingness column, I adapt the formula to input missing data for the baseline phase. Baseline phase data span row B2 to B7. I am entering 7. Okay, enter. And 19 is our baseline missing data point. I'm entering it and labeling it. This process should also be repeated for the intervention missing data point. I am revising the formula again, this time for the intervention phase. The intervention phase covers rows B8, B15. I am entering them and enter. I receive this value and I am importing this data and labeling it. Okay. As the third step, I need to run the formula in the numerator of OLS column. The formula should be adapted based on our dataset. Because the baseline data span B2 to B7, I am rearranging the formula accordingly. B2 to B7 and A2 to A7. Okay, and enter. Then, to calculate the corresponding values for all baseline data, I drag the bottom right corner of first calculated value cell with the mouse cursor and to row where the last baseline data is located. Okay. As the fourth step, I now need to run the formula in the denominator of OLS column. Because baseline data covers B2 to B7, the formula should be A2 to A7 and enter. Now, to calculate the corresponding values for all baseline time sessions, I drag the bottom right corner of the first calculated value and to the row where the last baseline time session is located. Okay. As the fifth step, I need to run the formula under the OLS B1 column. Actually, even though there is no change in this value due to blank rows, we can adapt the formula for our dataset. E2 to is 7 and F2 to F7, enter. As you see, we obtain the same value. The next step 6 is to obtain the intercept value of OLS. I need to adapt the formula under OLS B0. Again, I need to consider baseline phase B2 to B7 and A2 to A7, enter. I now have both the trend coefficient B1 and intercept value B0 using the OLS formula. In the following step 7, I run the formula to calculate the damping coefficient for our dataset. Because the end of the full dataset is at A15 and the end of the baseline session is at A7, I rearrange the formula accordingly and enter. Now we have a damping coefficient. As the 8th step, I need to operate the formula under the time variables column to obtain the effect of damping trend over time. The first value does not change. The second and next times change according to damping coefficient. But we do not need to make any change to the formula. Only we should drag the bottom right corner of the first calculated value cell and to the row where the last time session is located in the AB graph, like this. Okay. In the ninth step, I need to obtain predicted values according to OLS results. Again, we do not change any operator in the formula, we should only expand the formula of the predicted values to the end of our dataset. As step 10, now we should check the predicted values. If a value falls outside the valid range, we need to apply the winsorizing method manually. In our data sample, there is no such value, so we do not need to apply this method. In step 11, we need to calculate residuals. For this, drag the bottom right corner of the first calculated value to the row where the last session is located in the AB graph, like this. Okay. Now we have the residuals of our dataset. In step 12, we should obtain relocated intervention data according to residuals and predicted values. We see that the formula falls outside limit of our data. First, I need to move this formula according to my data position. I am cutting it and pasting it to the order of the first intervention data, like this. Okay. Now I should adapt the formula to obtain relocated intervention data. First, intervention residual starts with M8 and we average Bayesian predicted values span K2 to K7. K2, okay, K7 and enter. Now I need to expand the formula for all intervention data like this. Okay. In step 13, we need to input the performance criterion level of the study. For this instance, we assume it is 100%. I am entering it. Okay. Now we can calculate PCEStrend 1 value for our dataset. As step 14, we run the formula in the column PCEStrend 1 to compute the effect size according to formula 1 for PCS in the appendix of the technical report. In our dataset, relocated intervention data span N8 to N15. I am rearranging them, okay. And predicted baseline values cover K2 to K7. I am entering them, okay. Okay, then enter. Now, I have just obtained the PCEStrend 1 value for our dataset. In step 15, to calculate the PCEStrend 2 value as offered in the Formula 2 for PCS in the appendix of the technical report, we need to calculate the mean absolute credit error. For this, first, we run the formula on the difference of baseline scores to get the difference of subsequent baseline values. I am dragging the bottom right corner of the first calculate value cell down to the rows just before the last baseline data point. Okay. Then now I can obtain the maze value, but I need to adapt the formula under the maze column. According to our baseline data position, I adapt the formula operators M2 to M7 for the baseline data residuals and Q2 to Q6 for the difference of baseline scores and A7 multiplying A6 and enter. Now we have maze value for our dataset. As explained in the technical report, the PCEStrend 2 value takes into account the extrapolation of the baseline trend into the intervention phase. To assume that this extrapolation cannot continue throughout the intervention phase, the formula associated with step 15 under column 4 PCEStrend 2 should be applied by considering the baseline phase length. Regarding step 16, I adapt the formula according to baseline phase length. So I am adapting it A7 and enter. We have just found the limit of the extrapolation should be 5. In step 17, now I can calculate the PCEStrend 2 value for my dataset. In our dataset, relocated intervention data span N8 to N15. I am adapting them. And predicted baseline values cover K2 to K7. However, we also need to consider extrapolating the baseline trend into the intervention phase. Because the extrapolation limit is 5, the operator should include predicted baseline scores up to K12. I am entering them, K2 to K12. Okay, then enter. Now I have just obtained the PCEStrend 2 value for my dataset. As explained in detail in both the first article of Aydin and Tanius introducing PCS and the subsequent technical report, PCS calculations also allow immediate effect size values of the intervention for single case data. The technical report suggests two formulas in its appendix. In step 18, I will show how to obtain the PCS immediate one. A similar logic to PCEStrend 1 is operated in this step. That is, the extrapolation of the baseline trend into the intervention phase is not considered. In our dataset, the first three relocated intervention data span N8 to N10. I'm entering them. And the last three predicted baseline values cover K5 to K7. I'm entering K5 to K7. Okay. And enter. Now I obtain the PCS immediate one effect size value for my dataset. As the last step, 19, to calculate PCES immediate 2 according to formula 2 in the appendix of the technical report, I assume that the baseline trend continues to the intervention phase. This logic is also parallel with the PCEStrend 2 calculation. In our dataset, the first three relocated intervention data span N8 to N10. I am entering them like this, okay. And the extrapolations of the baseline trend into the first three intervention sessions cover K8 to K10. I am rearranging. Okay, and here. And enter. Now, I obtain the PCES immediate to effect size value for my dataset. So, I have just obtained all the values using the Google Sheets tool. I hope this video will be useful for those who will be using PCS analysis in their single case studies. As a note, this version allows trend incorporating PCS calculations only when baseline data show a therapeutic trend. Subsequent versions are under development to enable PCS calculations without trend and to incorporate confidence intervals and weighted calculations in meta-analysis studies. All versions that will be developed will be accessible sheet by sheet throughout the link in the technical report. Take care.